Hello, I'm Brian Lasser, President of Xenix Software. In this short video, I'm going to show you how to define objects using a feature that we call RenderText. It's not unusual to run across objects in the target application that are not recognized. In some cases, the object does not have a window handle and is not recognized by the window manager. Others may be custom or third-party objects. There are two categories of these objects, text and images. AscentialTest has very good testing support for both categories. This video topic addresses text. Images are addressed in another Xenix software video. We decided to call this ability to capture textual-based objects from text drawn on a screen or page RenderText, because it renders or makes an object where an object does not exist. In the simplest cases, text is used as a heading or label in the target application. In the most complex cases, text is arranged in rows and columns to form a grid or table where the rows scroll in and out of view. RenderText has been designed to support both simple and complex cases. Let's start out by looking at a few examples. The label Outlook Summary is drawn on this form. It's not a standard static text object, but RenderText recognizes it as an object just the same. So as far as the user is concerned, it can be used like any other application object. Now let's examine a more complex example. This is a custom object. It does have a window handle, but because it's non-standard, it is not recognized as a table. However, using RenderText allows AscentialTest to recognize and interact with it as a table. Notice first that I've used a special class to define the object. The class is called RenderScrollingTable because we know by the scroll bar that this table will scroll its rows in and out of view. I defined the table header, which provides a name for each column. I use the path statement RenderText @vertorder = 1 and grouped all the objects that share that attribute together as one object. The header labels are recognized as RenderText, and I simply drag them over to the header to define them. I created a class to represent the rows in the table. The path of this class excludes the header by specifying that the table rows have the attribute vertorder set to a value greater than 1. Notice that when I click on the class, the rows light up, but the header does not, since I excluded it. The objects in the row are also recognized using RenderText, and a path statement option called OverlapX assures that the row objects will be recognized even when they are not in view. Notice that the path statement for the objects in the first column reference the column header field track. AscentialTest's row selector feature also plays a role in RenderText table recognition. Selectors provide a way to locate a row based on a known value in the row. Since I'm interested in selecting a row based on song title, I've created a selector on the song column. The path uses RenderText to identify which column the selector will search. It also provides a variable or search term to locate the row. Watch what happens when I type Thriller into the test value column. AscentialTest locates the row based on the value that I searched for. I can use that selector to get the track, artist, album, etc., or to click the purchase button or the more info link. Let's see how. To verify the artist for a song in which I might be interested, I'll check on the artist that I want to verify, and then I'll use the step builder located below the snapshot image to complete the action. I'll input the value of the selector, in this case I'm interested in Thriller, and then I'll insert the action into my step. Let's add an action to purchase the song. To do that, I'll click on the Purchase button in the snapshot and then select Event in the Step Builder. I'll accept Click as the default action. Now I'll input Thriller in the Selector Value field and insert it into my step. When the test is run, AscentialTest will locate the row based on the value of the selector. If the row is not in view, AscentialTest will scroll the row into view. As you may already know, most steps are created in AscentialTest to be reusable. So instead of hard-coding Thriller, I'll want to make that variable. I've already created a parameter so that I can show you how easy it is to parameterize my step. I'll drag the parameter into the value fields. That way I can pass a value into the step from a data table when it comes time to implement this step in a test. I hope that you found this short video on AscentialTest's RenderText capability informative. If you would like to learn more, please visit us at www.zenix.com.